Assalamualaikum and good day everyone. Okay, today we're going to continue our lecture on multiplexer. Okay, so generally what is multiplexer? Multiplexer is that we have several input to several output. Okay, multiplexer, we have several input and we have only one output, and we have a selector. Okay, how about demultiplexer? Demultiplexer is opposite, where we have one input, then we have a lot of output. Okay, this is multiplexer and this is demultiplexer. Okay, demultiplexer we sometimes call it as just mux. Okay, so I will use this module for teaching. Okay, you guys may refer to the slide for complement. Okay, it's better for you guys to refer both the module and also the slide, so you have a full coverage of the knowledge and skills that you should have. Okay, I provide only summary. Okay, so okay, multiplexing means many into one. This concept is widely used in telecommunication to transmit information from multiple sources through a common channel. In digital circuits, a multiplexer, also known as a data selector or just mux. Okay, so in question, if they ask you data selector or mux, you should know this is actually referring to multiplexer. Okay, so the same person, just different name. Okay, just like Adi Lokman, someone call him Adi, someone call him Lokman, but he is still Adi Lokman, so it's just different name. Okay, in general, the multiplexer has one data output, n data selector input, and two n data input. The selector input determine which input data line is connected to the output line. The smallest multiplexer is the 2-to-1 multiplexer, or 1 out of 2 mux. Okay, if it's mentioned 2-to-1 multiplexer, means it have 2 input and 1 output. Okay, and 1 out of 2 multiplexer is the same, means this is your output and this is your input. Okay, so let me go first. Okay, so for multiplexer, okay, in general it have for multiplexer, it have one data output. Okay, it have n data selector input, and it have 2n data input. Okay, so what does it mean by this? Okay, now we go to the simplest one, which is 2-to-1 multiplexer. Okay, mux, the way to write is like this. Okay, and 2-to-1 means we have input 0 and we have input 1. Okay, and this is our output, and this is our data selector input. Okay, 1. Okay, we can put hash, so this is the logic symbol. Okay, you see this one, we have 2 input, right? So 2 what? 2 1. Okay, so this one is the combination of the data input. Okay, and how about this one? N data selector input, this one. Okay, n, which here is n is 1, so this one is n equals to 1. Okay, and of course the very obvious one, 1 data output. Okay, what unique about multiplexer is that data selector will select which input to be considered, and this input will be reflected at the output. Okay, so let me see for the first operation. Okay, you see this one, there is actually, you can, let's say you imagine this as a 3 inputs. Okay, then you have S, I1 and I0. Okay, as your combinational input combinations. So you have a 0 0 0 0 0 1 0 1 0 1 1 1 0 0 1 0 1 1 1 0 1, 1, 1. So you have 8 possible combination, right? Because this is 2 to the power of 3. So you have 8 possible combinations. Now, let's say this y is your input, okay? And y is your output. So what happened is that in data selector, if it it can have two value, right? Either 0 or 1. So if it's 0, okay, if it's 0, it will choose the value of I0. If it's 1, okay, it will choose the value of I1. Okay, so let we see. Okay, we'll make some boundary first. Okay, so now if you see this is are all 0, means it's only considered I0. Okay, so here you have 0, 1, following I0, 0 and 1. Okay, I think it's quite easy. And how about 1? If the data selector input, okay, is equals to 1, then it will choose now I1. So simply like that. Okay, and then when you see this, you can actually summarize it, okay, into a function table. Okay, this one, as you guys know, we call it truth table. Okay, and we can summarize it, simplify it. Okay, we obtain the function table. Function table where you have your S, okay, is a data selector input. Then you can have is either 0 or 1, correct? Am I correct? And your Y is the reflection of the input. So it is either I0 or I0. So we can see, right, when S is 0, whenever S is 0, it will the output will follow I0. So this one I0. Okay, and for S for 1, whenever S1, the output will follow I1. So I1. So this is your function table. Okay, so it's quite easy. So far so good. Okay, don't forget the name. Okay, and 2 to 1 multiplexer, 1 out of 2. Okay, because if you don't really notice, maybe you end up drawing the demultiplexer. Okay, but this one is actually multiplexer. Okay, and then once we have this, we try to see the schematic diagram, the corresponding schematic diagram. Okay, so now we see, okay, we have I1 as your one input, and you have you have I0 as input and I1 as your input, right? You have both I0 and I1. Then you have the S. Okay, the S, because you see there is 0 and 1. Okay, S is the determining factor. So let's say you have your S. Okay, let's say this one is the not. Okay, so the first thing okay, if you see this one S0 and Y I0. So for the I0 is will follow, it will need to have S inverted, right? So S inverted. Okay, S inverted, then you have your N here. Okay, how about I1? I1 is 1 for the data selector input, so is 1. You collect, you make a branch with S equals to 1 and here. Okay, then it is N. Okay, and then the answer, the Y can be, sorry, sorry, this wrong drawing. So the output can be from here or here, then mean or. Okay, is that easy, right? So you can refer this to figure 8.2. okay, sorry, I don't know why my lighting is blinking. Okay, sorry for the interruptions. Okay, the circuit choose one of two input data line, shows the logic, figure 8.1 shows the logic symbol, truth table and function. Figure 8.2 shows the schematic diagram of the 2, 1 marks. Okay, S is the data select input, which select either I0 or I1 to be passed to the output. From the truth table in figure 8.1b, Okay, so the effective equations for the multiplexer, okay, for the multiplexer of this situation, which is 2 to 1, okay, 2 to 1. So you have your input, right? Okay, and you take one which is have the function of what you see this one, it is a sum of product, right? Sum of product. This is or, this is n, so sum of products. So you should have sum of products means okay, and you see sum of product we always refer to y1, right? So there is how many? 4. If you want to write in sum of product, you can write in product of sum, no different, it's the same. Okay, sum of product for this one, you see S01 and this one, okay, for here you have your S is bar, okay, and I1 is also I1 is also I bar, and you have I0. Okay, how about this one? The same as I1 and I, no, 0, and then the other one you have S and I1 and I0 bar. Okay, and this one is S I1 I0. Okay, so it's the easy. And then actually this is a complete. We can try to simplify it further. Okay, when we want to simplify it further, we follow this one. Can't you see this one? Okay, so it's actually y equals to S bar I0 plus S I1. Okay, so it's easy. Okay, the same goes for the for marks of extended. Okay, we can have 4 to 1 multiplexer. Okay, so 4 to 1 multiplexer is the same. You can have 0 0 0 1 1 0 1 1 combinations, means you have 4 possible combination of SO and S1. So if it gets 0, okay, both of them 0, they will choose this one as the output. If they have 0 0 1, it will choose this one as the output. Going through this means Y will become I1, and so on. So it's quite easy, right? And then you can try to draw your own schematic diagram for multiplex of 4 input and 2 data select input. Okay, the concept is the same, even though we can expand the multiplexer to more bigger. Okay, we can have 8 1 16 1, okay, for example. Okay, now multiplexer applications. Okay, one of the application is that we can select data one input out of several different input. Figure 0.85 shows a scenario where multiplex is used to select one of 4 outputs from a function generator. Okay, so this is your function generator. Maybe you guys didn't know what a function generator. Function generator is a generator where it will produce a signal. Okay, it's produce a signal of varying frequency. You can select 1 kilohertz, 2 kilohertz, and so on. Okay, and also many other function generator. You can Google if you want to know more. Okay, so in here the function generator is actually specified to produce different frequency. Okay, different frequency. So so here for I0 we have a signal of 1 kilohertz, and I1 500 hertz, I2 250 hertz, and I3 1 to 5 kilohertz. Okay, as you notice, okay, this one is additional knowledge for you. As you notice, as the frequency is increased, the signal become more compact. Okay, when it is more compact, we can see there's a lot of complete cycle. Okay, there are a lot of complete cycle per time. So here you see there's a lot of complete cycle, right, compared to this. Okay, the lower the frequency, your complete cycle is reduced. Okay, when your complete cycle is reduced, F equals to 1 over T. When this is reduced, means your frequency is, sorry, when this you have more complete cycle, okay, then your frequency is what? You see, let's see, this t is 10 second, okay, for example. This one 10 second also. This one 10 second, this one 10 second, okay. For example, for this I3, for it to complete, it need 10 second. Okay, it need 10 second. 1/10, which is 0.1 hertz. Okay, how about this one? It needs how many? It needs 5 to complete. Okay, so F equals to 1/5. 1/5 is what? 0.2. So you can see the hertz is increased. Okay, means the higher the duration, the lower the frequency. Okay, so skip that already. So okay, this one the same operation as this. Let's say we have 0, 0. Okay, for the combination of this S1, S0, it will choose 1 kilohertz. If it's 0, 1, it will choose 500 hertz. If it's choose 0, 1, 0, it will choose 250 hertz, and so on. And the same goes for the last one. Okay. Now, okay, a 4-bit max consisting of quad to 1 multiplexer controlled by a common select signal. Okay, what does it mean by quad? Quad means 4. Okay, means 4. Multiplexer controlled by a common select signal. So okay, this is the full schematic diagram. Okay, where you can see A0, B0, A1, B1, A2, B2, A3, B3, A3, B3. Okay, let's say our S is 0. Okay, let's say our S is 0. What happened? When S is 0, it will choose A0, A1, A2, A3 if your S is equals to 0. Okay, how if your S, the data select input is S1, then similarly it will choose B0, B1, B2, B3. Okay, you see there is no difference between this chip to this chip and this chip. So you can from the schematic diagram, okay, you can make brief compact, okay, logic symbol. Okay, here, okay, you have A, B, Y. So if you have here like this means that there is 4 inputs of A. If you have B4, there is 4 inputs of B. Okay, and you see this select, data select, and if it's 0, you can see the information, right? If it's 0, it will choose this to go to here. If it's S equals to 1, it will choose this one to go to here. Okay, and you see here also mentioned 4, means this there is 4 output. Okay, you see there is 4 input from A, 4 input from B, and 4 output as the results. Okay, so a set of multiplexer can select a word or data from 2 or more data sources. Okay, figure 8.6 shows a quad. Okay, you guys can read this. Okay, I did okay, if you guys didn't have module, you can read. Okay, so why one of my decision is to teach from module is that I know some of you didn't have the module, so at least when I teach, okay, you have the chance to see the pages. Okay, that is one of my intention. I hope you guys appreciate. So other than it, I want to do the demonstration more. Okay, rather than reading the slide or referring to the slide, you can read your own. Okay, the important thing is you can have the page of the module to be read, and you have some demonstration. Okay, so that you know how to answer things. Okay. So another application of the multiplexer is for implementing Boolean function. The multiplexer enable any truth table to be implemented directly without Boolean function, minimization, and making get connection. In general, any n variable Boolean function can be implemented directly using 2n to 1 multiplexer. Okay, in general, okay, let me sketch this. Okay, in general, if you have n variable Boolean function, okay, it can be directly implemented using 2n to 1 mux. Okay, what does it mean by this? Let's say you have 3 variable Boolean function, 3 variable Boolean function. For example, A, B, C, right? This one is 3 variable. Then you will have to add. Okay, you have add to 1 mux. Okay, So this is that easy. Okay, that's all. Then if this means that you have add input, and when you have add input, and how many data select input you have. How many data select input you have? You have n equals to 3. So you have 3 data select input. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, as your as your input, and your data select input, you have you have S2, S1, S0. Okay, then output only 1. Okay, so this is okay. So if you guys don't understand, please feel free to approach me. Okay, now implement the XOR function using 4-1 multiplexer. Okay, connect input representing the min term. Remember, it means that min term, when we min term, we refer the function of output of 1 to logic 1, and the rest to logic 0. Okay, so we have this implement the XOR function. Okay. So you have this as the input 0, 1, 1, 0. So let's say you have two combinations, because it mentioned 2, right? It mentioned 4 to 1 multiplexer, means this one is your 2n. Okay, n is your equivalent to your number of select input, which is 2. Then we have 2, 2 means you have 4 input. Okay, so you have 4 inputs. Okay, so you see XOR function. What we can derive from X function? XOR function, you need to guys understand first what is XOR function. So XOR function, you see 0. We see this function from the function table: 0, 0, 0, 1, 1, 0, 1, 1. Okay. When 0, 0, what answer it will get? It will get answer from here, which is 0. With 0, 1, we get answer from 1. Okay, and so on. So you guys, if you want to know, to understand more about the XOR, I think you guys previously learned, right, from your lecture, what is XOR? What is the condition of input that you can have some corresponding output for XOR function. Okay, you guys can refer to the previous lecture. It's quite easy. Okay, now implement f equals f of variable ABC equals to sigma m 056. So this one is smaller m, so means it is a min term, and it's a SOP. Okay, so implement on at 1 marks. So this one is quite straightforward. So you see there is until 6, and there is 3 variables. So for sure you have 0, 0, 0. You have 8 possible combinations. Okay, and of course, because this is 2 to the power of 3 inputs, then your data select input is n equals to 3. Okay, so you have 3. So it's that, I think it's very straightforward. And the function, okay, the function, you see, for 0, 0, 0, it will have a function of 1. So means I note is 1. For 0, 0, 1, it will choose this one, which will have a function of 0. So here 0. Okay, because f will take the value from the selected input. Okay, from the selected input. This one is data selected, this one is a selected input. Okay, so you guys can try this. Okay, you can try this and read. Okay, for those that doesn't have the book, don't worry. Okay, I hope you guys can see this. Okay, for those that doesn't have the book, okay, you can pause the screen later on to try on yourself. Okay, the next we go to the multiplexer and expansion. Okay, so sometimes we need to combine multiplexer, few smaller multiplexer, to build a bigger multiplexer to perform much more input. Okay, to perform to consider much more input for our single output. Okay, so this condition usually that we have a lot of input. Okay, and we have a small chips. Okay, so this provide flexibility for you to not, to directly maybe buy the bigger chips, whereas you can use the existing small chip that you have. You just need to expand it, for example. Okay, So here is just the same. Okay, so here you can see it's implement a 4-1 marks using 3 markers. Okay, using implement 4-1 marks using 3-2-1 marks. So you please see this. So it means that you have 4 marks multiplexer, and implement a 4-2-1 means you have 4 input. Okay, and of course you only have 1 output. Okay, and then the special part is that must have a multiplexer have data select, so you don't forget to draw the data selected input. Okay, then after that, from here if we go to the next, okay, the next as the next input, the second stage, and this one also. Okay, so if this your I0, I1, I2, I3, okay, it's that simple. Now you can see this is the same, this is the expanded version. Okay, as long as you guys understand the concept, we don't need to discuss much more because it's just an expand. Okay, if you guys understand, feel free to ask me, okay, in the class or in WhatsApp later on. Okay, now we go to the next is a multiplexer integrated circuits. Okay, multiplexer integrated circuits. The 7400 logic family has a several multiplexer integrated circuits. Several are listed in table 8.1. Okay, several, we have more. 4 of them are described further in this section. Okay, in this section we only consider to describe more about 74151. Okay, 74153, and also 74157. Okay. Now all multiplexer described here except for 74 times 152 have active low enable. So what do you understand about active low enable? Okay, enable is actually, okay, enable is a function in the multiplexer. Okay, if you select, if the enable is 0, okay, mean the multiplexer is disabled, means not functioning. Okay, but if the enable is 1 or active, then the multiplexer will be functioning. Okay, so it's just like you can imagine like a switch. Okay, and then if you the enable is disabled, then your output will always low. Okay, unless your output is the inverted, okay, inverted output. So if you have enable your enable is disabled, your multiplexer will produce low output, but it will produce high output if your output have a not like this. Okay, I think it's understandable, right? Okay, now without further ado, we proceed. Okay, figure 8.12. Okay, describe the 74 times 151 multiplexer IC chip. Okay, 2 outputs are available, which Y has the same value as the selected input and W has the inverted value. Means whatever you have as Y, let's say Y is 1, your W will be 0. If your Y is 0 and your W will be 1, it's always inverted to Y. Okay, now the 74152 is also an 8.8 to 1 multiplexer, very similar to 74 times 4, but it does not have enable input or non-inverted output. Since it need 2 fewer signal, the package has only 14 pins. Okay, what you guys maybe you guys don't understand is that, okay, you see this is 74 times 151 multiplexer IC. Okay, here we have this one. Okay, and then they mentioned 74 times 152 is also 8 to 1 multiplexer, very similar to 74 151. But what it doesn't have, okay, what 74 1 times 152 doesn't have compared to 74 times 151 is that it doesn't have the enable. Okay, it doesn't have enable inputs, and it doesn't have the non-inverted output. Okay, it doesn't have the non-inverted output. So you guys have to understand this. Okay, you guys have to understand also to memorize some, okay, of the function. Okay, of the chip. Okay, so okay, now I don't want to, you guys can read this on your own, okay, the solution, but I think I need to read the example first. For a 74 times 151 multiplexer, okay, what are the value at the outputs of the state of the selector input S2, S1, S0? Okay, so they give us combinations. Okay, they give us combinations S2, S1, S0. Okay, they give us S2, S1, S0, S0, 1, 0. So this one will be 0, 1, 0. Okay. Okay, and then you see, I want to so maybe you guys didn't aware. Okay, you see there is a small number here, 11, 10, 9, 7, 12, 13, and so on. This is actually the pin number. Okay, so when you have the chip, right, you have several leg. Okay, you have several leg, and normally chip will maybe sometimes have this to show where is the counting of one started. Okay, for example, let's say you can have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the number of the leg. Okay, so this is why there is a small number here. Okay, now we see for first, okay, we need to see the main prioritize here is the enable. You see, when enable is high, okay, I need to take my eraser. Okay, so okay, first you make you see there's a 7 combination, right? You have 7 combination of inputs. This one is actually 2 to the power of 3 equals to 8. So you should have 8 combination of input, and because this is 3, so you have 3 data select input. Okay, so first, enable can be high or low. Remember, I told you now is if enable is disabled, the multiplexer is disabled and will provide low output unless it have inverted output, then it will have 1. Okay, so okay, for G, okay, important one, okay, let's say G is high. When G is high means like this. G is high means okay, when G, you see, when we put G here high, okay, when we put high, what happened when it pass through this? It will be disabled because it is G inverted. Okay, G inverted. Okay, so when G inverted, okay, let's say you put two possible, right, value of G, whether it's high or low. So if it's high, then the inverted is 0, right? So the demultiplexer is disabled. Okay, when it is disabled, we don't care about the combinations of the data select input. That's why we have don't care here. And what output that we always have if it's disabled, okay, regardless of whatever you have here, the output will be low if the multiplexer is disabled. But this one, because it have inverter, that's why it's a high value. Okay, enough with that. Now let's say the second situation where we have the G is low. If the G is low, you can see inverted, then the device is enabled. Okay, the device is enabled. You can see this one, right? This one simply means that the device is active low or active high. Okay, so this one is active low. Okay, active low. It's if it's low, then it is enabled. Okay, so you see, then there is possible combination L and L, L and H. This is, if you guys don't understand, actually this is just like 0, 0, 1. Okay, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, and so on. Okay, so now for L, this one settled. If it's L means the multiplexer is enabled. Now if we have combination of S2, S1, S0 is 0, 0, 0, mean it will take this one. Okay, it will take this one to flow here. Okay, so that's why you have D0, and W is just inverted of Y. So is, I think this is quite straightforward and you guys can understand. Okay, the next we go to the 74 times 153 device. Okay, the 74 times 153 device shown in figure 8.13 contain two multiplexer. Okay, you see there is two multiplexer here. However, they are not independent multiplexer because both multiplexers are controlled by common selector inputs. Okay, here you have 2. So if you have 2 to the power of 2, so you have 4 combinations. Okay, you have 4 combinations of input. So this why you have 1, 2, 3, 4, 1, 2, 3, 4. Okay, is what 4 because there is 2 multiplexer. Okay, and this one is the enable circuits. Okay, so if we enable high, because this is active low, so the multiplexer is disabled. So when it is disabled, regardless of whatever combination of S1, S0 that we have, our output will always low. Here will be low and here will be low as well. How about if this one is low, then it is active, because this one is active low. So when it is active low, then you have L1, L0, L, which is 0, 0, mean it will take 1 C0 and it will take 2 C0. Okay, so it will take 1 C0 and 2 C0. Okay, the output is C0. Okay, if it's 0, 1, it will take this one 1 C1 and 2 C1. So okay, I think it's straightforward. If you guys don't understand, feel free to ask me. Okay, this one you guys may read yourself. Okay, the next is 74 times 157 device. The 74 one-time device shown in figure 815, okay, is a quad 2-channel multiplexer. What does it mean by quad? Quad is 4. Okay, 2-channel multiplexer. That means it has 4. It has 4 2-to-1 multiplexer. Means it have 4. Okay, we have a 4 2-to-1 multiplexer. Okay, inside. Okay, inside. Okay. Respectively, the selector input is sometimes labeled as A bar B. Okay, the selector input. This device is commonly used to implement the nibble selector shown in figure 8.6b. Okay, the nibble selector 8.6b. Let me see 8.6b. Okay, this nibble selector. So you know what is nibble? Nibble is half of byte. Okay, 1 byte 8 bit, 1 nibble 4 bit. Okay, sorry, 1 byte 8 bit, 1 nibble 4 bit. So this is just like a nibble selector. Okay, so the function is the same. Okay, this one you see, this is active low, means whenever if it's high, so what, regardless of S value selectable, the output will always be low. However, if it start to be we put the low because it's active low, so the selector we have to value with either L or H, right? If it's L low, it will choose all the value of A, because you know it's actually we have 1A, 1B, 2A, 2B, 3A, 3B, 4A, 4B. Okay, because it's actually 4 2-to-1 marks. Okay, inside here, so you will choose all the A's. Okay, if it's high, if it's 1, it will choose all the B's. Okay, the demultiplexer. Okay, the demultiplexer perform the inverse of the multiplexing function. Inverse, like I told you guys, if marks is many to 1, demultiplexer is many is 1 to many. Okay, demultiplexer has 1 input and selector input and 2 and output, so just inverse. Okay, and select input, 2 and output. The binary combination at the selector input determine which output receive the data input. Figure 0.816 shows 2 demultiplexers. So you see there is 2 demultiplexer. This one is 1 to 4 demultiplexer, 1 input, 4 output. 1 to 8 demultiplexer, 1 input, 8 output. and this is the data select input. Okay, now demultiplexer are widely used for long distance transmission, where the transmission line is the most expensive components. Okay, you guys can do this yourself. The figure 8.17 shows a simplified view of using multiplexer demultiplexer for sharing a common transmission line among 4 transmitter receiver pair. Okay, so this is in the channel, for example, in the channel communication. Okay, so transmission line. Okay, you see from transmission line from the transmitter and from the receiver. Let's say from transmitter we have several inputs. Okay, but we want to select which input to be given to our output, so that's why we have marks. Okay, here. And when we already transferred the transmission, the signal, then we want to select which receiver, which parts of the receiver should receive our signal. That's why we have demultiplexer. Okay, we choose which output. So they are like a couple. Okay, so with that we finish with multiplexer. It's quite straightforward, and you guys can try this. Okay, please try. Okay, and maybe Hui, please create another discussion at our forum for chapter 8 exercise, module exercise. So with that we finish on multiplexer. Okay, see you guys and have a nice day.